5.6, and this has to do with the rules of exponents and being able to write a number in scientific notation using exponents. So exponents are these numbers, this 2 to the second power, that's the exponent, 2 to the third power. So 2 to the second would be written like this. You'd write it 2 times. 2 to the third would be written like this. And if you count them, you have 5. So the rule illustrates that when you multiply them, you're going to end up adding the exponents. So the general rule is that the product rule is that if you are multiplying two, they have to have the same base, you are going to add the exponents. So 3 to the third times 3 to the second becomes 3 to the fifth, which is 243. Most common mistakes is students make it 9 to the 5. Okay, it does not become 9. Okay, the base stays the same. This number never changes. Okay, when you do it. So if I had 2 to that's not what I wanted to write, but I'll do it this way anyways. If I had 3 to the second times 3, even though we don't write it, there's a 1 here, this would be 3 to the third, which would be 27. So sometimes they might ask you to write it with the exponent. Sometimes they might ask you to evaluate it. So you have to be prepared to write it both ways. So if I had 4 to the third times 4 to the seventh, it equals 4 to the 10th, which comes out to be 1,480,576. And again, you could just put 4 to the third in your calculator times 4 to the seventh, you get the same answer. But what answer are they looking for? Are they asking you to write it as an exponent, or are they asking you to evaluate it? So you do need to be able to do this one. If it's a negative, if one's negative and the other's not, then you can't just add them, okay? Because now the bases are different. So this I would evaluate to be 16. This I would evaluate to be 64, and I would multiply them. So in order to add the exponents, the bases have to be the same. So now if I did it this way, negative 4 to the second times negative 4 to the third, okay, now I can add them and get negative 4 to the fifth, and that comes out to be negative 1,024. Okay, the bases have to be the same in order to be able to add the exponents. So up here, you would have gotten the wrong answer had you done it that way. Okay, so general rule, if I was just using x to the third times x to the seventh is going to give me x to the 10th. I'm going to add the exponents. The quotient rule is when you're going to divide, you're going to subtract the exponents. And of course, a can't be equal to 0 because you can't divide by 0. So that can't be the base. So again, 3 to the 7th divided by 3 to the 5th is 3 squared, because you're going to subtract 7 minus 5. And again, the 3 stays the same. 5 to the 9th divided by 5 to the 5th is 5 to the 4th. So again, if I had negative, they both have to be negative in order for me to do it. So I have negative 5 to the 7th divided by negative 5 to the 3rd. That's going to give me, that's not what I wanted, but that's okay. I'll do this, negative 5 to the 4th. Now I'm going to put that in my calculator. I have to make sure that I use parentheses when I do that in my calculator. Negative 5 to the 4th. Oops, I got an error. I hit the wrong button. Negative 5 to the 4th. I've got 625. Okay, but again, these both have to be the same in order to do it. So again, general case, x to the 7th divided by x to the 10th divided by x to the 7th. You subtract the exponents and you get x to the 3rd. General case. So no matter what the number is, as long as it's the same, you just keep the base. You don't change it. Anything to the 0 power is 1, and we did that in the last chapter where we were changing the bases. Always the last column was the ones column because the base was raised to the 0. You just have to be careful, though, when it comes to parentheses. So like this one, 2 to the 0 is 1. That's good. And this is everything's in parentheses, 2 to the 0 is 1. This one, because of PEMDAS, happens afterwards. So that becomes negative 1 times 1, that's negative 1. This is 1, and then this is 5 times 1. So notice the difference with or without parentheses makes a big difference, okay? So the x to the 0 gives you 1, and then it's multiplied by 1. So you have to notice that whether it's in the parentheses or not. Okay, and then this is the negative exponent. If you have something to a negative exponent, it means 1 over that, and then the exponent becomes positive. So 3 to the negative 2 becomes 1 over 3 to the second, which is the same thing as 1 to the ninth. 7 to the negative 1 becomes 1 over 7 to the first, which is 1 over 7. So the negative exponent just means that you're going to make it 1 over. So in other words, 3 to the negative third means 1 over 3 to the third, which is 1 over 27. 2 to the negative 4 is 1 over 2 to the fourth, which is 1 over 16. Notice this, negative 7 to the second is just simply negative 49, okay? It has to be the exponent has to be negative in order to make it 1 over. Just because the number's negative, that doesn't mean it becomes 1 over, okay? You're looking at the exponent to be negative to make it 1 over. And the last rule is the power rule, that if you have an exponent raised to another exponent, now you multiply them. Okay, so an exponent raised to another exponent. So this would be 2 to the fourth, and it would be 4 times 5, which is 20. 7 times 2, which is going to give you 14. So a power to a power gets multiplied. So if I had something like this, 3 to the second raised to the third, that would be 3 to the fifth. 3 to the sixth would be nice if I could multiply, and that's 729. If I had negative 2 to the negative 2, all raised to the negative 2, negative 2 times negative 2 is 4, so that's just going to be a simple 16, okay? Because these two negatives canceled each other out, made it positive, so there's no 1 over here. But if let's say if I had this 4 to the negative 1 to the 2, that would become 4 to the negative 2. That would become 1 over 4 squared, which would be 1 over 16 because of that negative exponent. Okay, so that's all the rules written right there. When you multiply, you add. When you divide, you subtract. Anything to the 0 is 1. Negative exponent makes it 1 over. And when you have a power to a power, you multiply. Okay, so now we use these negative exponents and these exponents in scientific notation. Many scientific problems deal with very large or very small numbers. For example, the distance from the Earth to the Sun is 93 million miles. The wavelength is 0.000 meters. So they don't like to write that. And a lot of times, even if you put in your calculator, it will give you the scientific notation answer, even though you don't realize you're looking at it. So it's a shorthand way of writing instead of writing all those zeros. So what happens is you move the decimal places here, even though we don't write it, the decimal place is here. We want to move it so that the number that we're going to write is less than 10. So it has to go between the 9 and the 3. So then you just count 1, 2, 3, 4, 5, 6, 7, and that's where this number is coming from. So I moved it over 7 places. When the number is really small like this, again, I want to make sure that the number goes back behind the 6 so that the number is between 1 and 10. Between 1 and 9, I should say. 1, 2, 3, 4, 5, 6, 7. And now it's negative. So when the number is really small, it has a negative exponent. Just ignore this 0. That's just a placeholder, but this really doesn't affect the number. Make sure you don't count it. Okay, so this is just the answer, how to do it written down. Move the decimal point in the original number to the right or to the left to obtain your answer. It has to be the numbers greater than or equal to 1 and less than 10. It can't be 2 decimal places. Count the number of places you've moved to obtain what the exponent's going to be. If the decimal was moved to the right, the number is to be considered negative. Multiply the number instead. So I just count the exponent. So let's see what we're going to do here. Okay, so if I'm going to write this in scientific notation, I want to, again, even though we don't write it, there's a decimal point here. I want to move it over there. So I'm going to have 5.8 times 10 to the 1, 2, 3, 4, 5, 6. Positive because it's a large number and you don't see the decimal. So now this one would go here and it's got to come all the way over here. So it's 3.106. You got to count all those significant numbers there. And now you go 1, 2, 3, 4, 5, 6, 7, 8, an exponent of 8. But this number right here, you have to go all the way back so that it's less than 10. But you have to make sure you write that 0.106 there also. Okay, so for this one, again, you're going to write more than, you don't see the decimal, it's here. It's going to come all the way back over to here. So it's 7.263 times 10 to the how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now this one, I see the decimal, which means it's going to be a negative. So I'm going to grab this decimal and move it to there. So it's going to become 1.1 times 10 to the, now I'm going to count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, negative 12. Okay, again, don't count that leading zero. Whoa, that doesn't even look like a 12. I got distracted. 12, there we go, negative 12. Okay, so for this one, again, this number's going to come all the way back here, and I'm going to have 4.92 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. Okay, so now we're going to go the other way and change it from scientific notation to a decimal number. So I'm going to go 1, 4, and now I'm going to count 8. Counting the 4, 1, 2, 3, 4, 5, 6, 7, 8. So I have to make sure I have 8. Whoops, did I stop again? 1, 2, 3, 4, 5, 6, 7, 8, including the 4 because the decimal was here. So now I have 1, 2, 3, I have 140 million. So same thing here. I'm going, this 5 is counting as 1, so don't just add 9 zeros on. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 3, like that. Okay? I just want to make sure I get this in. Okay, so now to go negative, that means I'm going to go left. So it's going to be here, 1, 2, 3, 4, 5. So it's going to be, if I moved it this way, 1, 2, 3, you can just put those zeros in to see what happened there, what it should look like. So for this one, again, I'm moving it to the left, counting the 3. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. So just count. 1, 2, 3, 4, 5, 6, 7, 8. So I should have moved 8. Don't just add zeros. And it's when it's negative, I know I was moving it to the left. So you can pause the video if you need to look at the directions more on how to do scientific notation. I have to make sure I stop this or it's not going to go on YouTube.